Again, say nothing. It's not working. Something is wrong somewhere. I don't know. No videos now. Okay. Video single snow. Audio single snow. Good morning. Good morning, everybody. Sorry, gentlemen. There's some problem in last transmission. Good morning, everybody. This is Engineer Suraj Singh speaking from Bharat, India on this January 21, 2022, Friday, this 3:42 a.m. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ आज जनवरी 21 2022 सुबह के 3:42 एंड टॉपिक ऑफ टॉक इज सेम एज यूजुअल quality, concrete specifications, civil field engineering, life, engineers, AnnexSL, Red, Silver, White books, safety, health, and environment, designs, construction, method, contracts, disputes, organizations, communications, coordinations, why quality of materials, works. Talk is 650. Okay, whatever number doesn't matter. Last video was I had some problems. There was nothing. So maybe 4 or 5 minutes have gone waste, or maybe it's online, but I won't care for that because it was not properly seen. There was some problem with Facebook. Now singles are of course at the moment they are, and therefore can say I'll turn to talk. Let us see this page as you can say. If you want to contact me is Suraj_engineer SURAJ Suraj_ENGINEER at yahoo.co.uk, and title is Chartered Engineer India, International Professional Engineer India, and I belong to Civil Engineering branch of engineering. Of course, that is basic branch. I belong. That's certificate. That's about International Professional in India. Valid up to this is Chartered Engineer India here. As you know, this is a fellow membership here. Of course, this is most of the file. I'm going to discuss the quality Bharat India, and of course, then I will go through to here. This is ACI concrete terminology. So this fellow membership, I close it now, and I also close this file of Chartered Engineer India so that yes. For now, I am interested in talking about equality in Bharat India based on title that I have here. We have to discuss about quality. That's a very important point on this talk, and every day. A very important point on behalf of engineering community and on behalf of people of this country now. Quality is very important, and that I think there's no equivalent to that. If you miss quality, means we miss ourselves. Quality applies everywhere. It applies to individual, it applies to work, it applies to materials, it applies even to personal in performance, it applies to every article, every good, it applies to every procedure. And in fact, it applies to education, it applies to profession. There's no place in life where quality doesn't work. Quality matters everywhere. It's not a question of testing or not testing, it's a question of how do you proceed. Then another point is this is quality, and we have to depend on materials in life, and materials means materials. I'm not talking about diamond or gold. I'm talking about very simple materials that involve development. These materials involve development, and development not involve the physical development. I'm talking, and not mental development. Mental development something else. It depends upon your own performance, own quality, character, how education, or concrete specifications. I'm talking of concrete, which is very important material everywhere in the world, and you can say concrete is kind of artificial stone, not natural stone, and it's very important, very expensive, of course, not in comparison to other materials, because it's long living material. I think it's more than life of individual. If you have to depend on some material in life for permanent use, it is concrete, it is brick, it is concrete block, it is mortar, or you can say other finishing items which can be replaced, but replacing concrete is very expensive and difficult. In your building where you live, without concrete you cannot live, you cannot produce building. Concrete is such a material. There was a time when there was no concrete. People used to work on stones and bricks. Bricks were also not available sometimes, so these were only very small tiles. And otherwise, you can say Stone Age. Stone Age doesn't exist now, but we have to know about that. We have to know about bricks, various sizes of bricks, standard size of bricks, and all these are part of engineering materials, which is a subject in engineering, not very wide subject, but without knowledge of engineering material, we cannot learn anything. Engineering materials have become very magnanimous subject now. when I was learning, I was a student, long back in 1971 to 74. At that time, engineering material was not that expensive or expensive as far as knowledge is concerned. Volumes were just one book and you have to pass that. And if you had to do some fundamentals of engineering materials, and you could say, yes, I qualified that. It's good one. You have to study bricks, you have to study stones, you have to study some mortar, you have to study, or you can say terracotta-like materials, or mortar or concrete. Or likewise, how it is done in field, very mud, clay like that means it's not very clear at the time, but you had to do it. Now it's concrete, which is part of engineering production, engineering works. No work can be done without concrete or without mortar. It's very specified material everywhere, and now it has become a technology itself. Concrete cannot be denied that it's a technology, very much vast, broadened material. And I think maybe I know only 5% of that, not more than that. I don't know 100% about conduct and behavior of concrete in engineering, in works, and nobody knows exactly how it behaves in long term, because it's not been there for thousands of years. Concrete is still unclear about its behavior. It has relations to environment, it has relations to temperature, heat, sun, wear, water, chemicals. That is what concrete, how does it behave, how does it conduct, and where can some problem be caused to concrete, how to understand concrete, how to do it, how to means just mixing and thinking is concrete is not enough. Maybe you see walking here and there, some building is under construction or some road is under construction, or some truck comes with ready mix and you accept that that's concrete enough. But that is only physical mode. If you go to technical mode, if you go to theoretical mode, concrete is different, means it's not mix alone that is concrete. It's something else, means ingredients, what sort of ingredients there, admixtures there, chemicals there, how they behave. That all we have to understand at various classes, at various descriptions, and you can say explanations and research work. People don't even understand these days. I have seen when engineers are not clear about concrete conduct. If you talk to some ready misplant person, you may not be finding an answer to certain questions, but okay, it's mechanism, plant is available, people are thinking it's quality work. To some extent, maybe quality work, the mixing is done qualitatively, that's it. But otherwise, what else is there? It's not clear. When you talk of field engineering means engineering field and life field. Field doesn't mean the ground here, it means a domain. Engineering is super domain. It's you can say like a domain covering all aspects of life, like medical science covers all aspects of life. Same way, civil, when we name civil, this means it's for everybody. It's for everybody. Even in defense forces, engineering is used. In all sectors of life, engineering and concrete are used. Concrete is a part of engineering. And also you can say concrete has a verb as well as its noun, means it's something we deal with material, and that relates to our life. Sometimes we take concrete quantity and think this shall be approximate cost of this structure. But we have to keep in mind that we cannot use concrete also unlimitedly. We have to use, this is material which comes from nature. That point we have to keep in mind. It's not material that's produced in machine. Mixing is done in machine, but material ingredients are not produced by machines. We crush rocks and rock is converted to, after crushing, coarse aggregate, or you can say stone chips or stone aggregate of different sizes, not globular but angular with various properties, and also from that we get some dust depending on, that's also aggregate, that's called fine aggregate. these stones which we say stone crushed stones, and these are called, you can say, aggregate, coarse aggregate, and dust is fine aggregate. And also water we use, that's also a kind of natural material, 100% chemical based water. We have to take into consideration all this, and it all relates to life. If you want a good house, or at least as people say, okay, I am not very rich, if I get a shelter for small shelter for me, you can say that's my destiny in life. For someone, a small house is destiny, and for someone having many houses do not satisfy that person. Okay, no problem. Now we have to deal with concrete, which is very important item, first item. Along with soil it is not independent. When we talk of concrete, we have to talk of soil also, because soil is very important material, original material, on which depends the strength of building, because building has to transfer its loads to soil ultimately, and building cannot say that this foundation is enough for this building, because foundation also is not ultimate responsive for whatever actions are imposed on building. So soil is also, though it is soil, people don't consider it as a material, but in fact it's very important, significant material, more than every other material. It's a material in a sense, not directly like concrete, we have to produce something. It's naturally available material and it's used in that form after improvement. It depends on what strength it is. After all, we also get rocks, that's also a part of soil, consolidated soil or volcanic soil or sedimentary soil or metamorphic, you can say. Same way it is soil, which is a part of existing nature, existing crust. Then all this is right. We have to construct something, we have to construct some structure, and that structure construction depends on, it's not automatic. We have to design something. We must have design, and then we can only construct. And that construction is done through some procedure, which procedure can be done by whatever method we know. If we have capacity, we can do it our own, because it's engineering that is clear about that. Someone has to do the construction, and that construction can be done directly by engineers or through some agency that is expert in construction activities, and that agency is called contractor. Contractor and owner who goes to ask contractor, do this for me, I pay you this much. So in that way you can say you cannot do everything yourself. There are so many activities involved in construction, particularly in structural construction, finishes and structures. Involves so many materials to be handled, to be procured, to be installed, to be erected, that this is a kind of a specialty, you can say, which require knowledge of materials, knowledge of how to use materials and how to install them. And you can install them only when you understand how to do that. And that's reason means everybody cannot know everything. So you say a contractor is an agency who knows about this and who has gone through experience, and whatever work they do, it shall be professional. And that's thinking that, keeping in mind, the contractor is professional or should be professional. We have to chart out that requirement. What is contractor, what is owner, and what is engineer. Or engineer, when I say, this means whoever works in designs and construction professionally can be called engineer. And when we say construction and designs, of course, how to do something, how to do some article, some work, some activity, what is involved, how it can be described. It all relates to explanation of method, elaborations, and contracts. What is contract? Because contractor means contract should exist, and contract should be, it depends on if you have trust, you can leave something to someone. Otherwise, as far as documentation is concerned, contract is also a very big item, very significant item of documentation for commercial purpose, for technical purpose, and for whatever purpose. At smallest level or largest level, at just a small work level or construction project level, or it may be at design and construction, or we can say EPC, engineering, procurement and construction. And when these contracts are there, these contracts are in force. Certain clauses, of course, are included in contracts, and various organizations do work. So there are chances and there are possibilities that there would be non-clarities or ambiguities, or there may be personal interests or companies' interests involved that can lead to certain kind of valuation disputes. And of course, then you can say so much work we have to do from design stage to completion stage, or you can say project stage is converted to operational stage or maintenance stage. And we can say a lot work is involved, records are required, and what we do, what we don't do, everything should be explicitly clear in documentary form. For that, you can say communication and coordination is involved. So we can classify like that. First is engineering project, then we have to say contracts, and we then can say all technical, non-technical, engineering based, everything, communication, coordination. Or just we say first design something and do something, or we can say plan something, do something, check something, improve something, right? Plan, do, check and improve is just we call in our organizational way, not in management way. I'm not interested in management, but I'm interested in organization, because management gives some kind of something. I know it's the kind of attitude it shows. Management, I don't believe in management, I believe in organization. The organs are defined, means body has some organs, and organization means a body, it must have complete organization. It should not say mandate, means management is something, you have to handle already given or described specifications, but we have to apply in the mind. And of course you may say whatever you say, I don't mind that, but as far as organization is concerned, is most valuable description. That's why in this title of this paper, this quality paper, and I especially entitled it Quality in Bharat, India. And you can see that various certifications here. As I showed to you, this is my email ID, suraj_engineer@yahoo.co.uk. Is by chance it is UK, otherwise I'm citizen of this country, Bharat, India, and I by qualification I'm a civil engineer. And here is Chartered Engineer India certification. I have an International Professional Engineer India certification for 5 years. So I started the certificate. I got first certificate in 2012, and then 2015 and 20. This certificate I am having now is issued on. You can see the certificate if you want to see. There's no problem to me, and that is here. This certificate was issued on 30th September 2020. Here you can see, and valid to 30 September 2025. It's running certificate, means it's not permanent one. Chartered Engineer certificate depends on, Chartered Engineer certificates, you can say, depends on what we say membership continuation, corporate membership continuation, but this certificate depends on for only 5 years it will applies, and then you have to renew it through various methods. In beginning, as far as international professional certificate, you have to appear in examination, and then you have to pass examination, and you have to appear in interview. And so there are the 2 stages. Actually, theoretical examination has 1 or 2 stages, then the interview is 3rd stage. So you have to pass these 3 stages. Only then you can be granted International Professional certificate, which is valid for 5 years, and then again and again and again. You can say it's a current certificate, running certificate. There's a certificate of professional engineer also, that's also valid for 5 years, but certificate of membership related chartered engineer is valid as far as one is corporate member, and once you resign your corporate membership, your chartered engineer designation also goes away. This is just brief of this. Then you can say here is this quality file, and it's very important for me to use this file every day, not because I am only smart. I'm not saying that. I have very small experience in my life. I'm very ordinary person. I'm not highly qualified engineer. You can say I'm not doctor, I'm not master. I am just like very small individual in engineering, but I trust in performance. I trust in knowledge. And knowledge, not just knowledge, theoretical knowledge, it should be applied knowledge, because theoretical knowledge is just theoretical. You have to, in engineering, you can't depend on theoretical knowledge alone. That point is very important to understand. In engineering world, theoretical knowledge doesn't matter. It matters to some extent as far as work is concerned, but theory has to be applied, and that's what we can say applied theory. We say in engineering means applied science, and science means science means logic, science means justification, science means explanation, science means observation of natural conduct, science means how nature works, how material works, performs, like that. How means we have to define what we have to do. That is what engineering is. Sorry. If I'm unable to define what I have to do, I can't explain. This means if I don't know how to do, what to do, how means what way to do, is vast way, how can I do? Tell me. If I'm in field, I'm working, how I have instruct people, means what you have to do. They will do their way. What's the role I have there then? Just to be present? No, it's not that. When I say one is an engineer, this means one is expert. Expert doesn't mean that level, but actually is having specialized knowledge that everybody else does not have. That specialized knowledge has to be worked upon, has to be applied, and that sources or resources, application of workers, our equipment, of materials. This means if I want to apply certain knowledge, I must know about workers, I must know about machines, performance, how to use machines, and I should know about necessary materials that would be involved to permanently include it. Permanently included or preparatory included or temporarily included, it depends on activities. Now my standpoint is quality. And don't be surprised that I'm talking only quality. Reason being, when I talk quality, quantity is already included, because when you specify quality, automatically material is involved, quantum is involved. Even if you do one work, one unit, quality is required, or do you perform or you produce 1,000 units, quality is required. Qualityless quantity has got no meaning, you may have to understand. Particularly those fresh engineers or budding engineers, or we can say developing engineers, who may not have exposure to those vistas which are required, and they have to. In coming future, they have to involve. I did not have this privilege when I started my career, but now privilege is available. We have communication medium, we have information available. Information is available on web. Yes, you have to see information is reliable or it's not reliable. So much bogus information, so much futile information is also available, which does not mean anything. Being an engineer, we can understand what information is reliable and what information is not reliable. It's not difficult to identify or to check. I have seen many people writing just for sake of writing, which has got no meaning. Oh, no problem, it's your choice if you want to. Means you can use medium, at least you are interested in using medium, and that's an important point. But when seriousness comes into play, quality is very serious material. It's very serious world. I should say without quality, nothing is possible. Sometimes we don't identify what we are doing, but quality is being followed. It's a part of convention, a part of process. And we just like we use natural materials, there's already quality in them. You can't change that quality. For example, you use stone, you take sand, you take steel. You may say, okay, this carbon percentage in that, or this is this percentage, nickel percentage, or this that alloy steel. Only that much you can say, but ultimately, major part of that is natural. You may say it's stainless steel, this mild steel, this galvanized. Okay, likewise you can say doesn't matter, but natural process never stops. Radioactivity goes on and on. Same way, you may say in 95% cases to 98% cases of materials used, this all come from natural production, where we don't have any role. We don't have any role in that natural production. But we have to depend on that if that materials are not available, we cannot say engineering would be available. Even in previous times, old times, mud was used, clay was used for construction purposes along with stone. Clay was used, even you can say adobe houses, if you just see in our country or other countries. Mud mortar was used, clay was used for construction of houses. But we still think, oh, it's very old, it's not modern. But I don't take that way. It was modern, it is modern. After all, there is no difference between this and stone shapes. After all, clay is also clay, stone is also stone, there's no way. Only difference is concrete is artificial and stone is natural. Some properties we inflict into concrete because of our knowledge, and stone is only just we say good in compression. Likewise, we know what, but clay, for example, is very important material. It is important and very delicate also. For some purpose, for agriculture purpose, it's excellent material. For construction purpose, it's not excellent material. That depends on, but it is material. It's a part of crust, it's a part of soil. Same way, stone, you may say igneous rocks we use, sedimentary rocks we use, and metamorphic rocks we use. These are major classifications in engineering. There may be more classifications, but these are major that we say this is powerful rock, this is very good rock, igneous rocks, Jawalamukhi, and this is layered base, sedimentation base, sedimentary rock, and this is sedimentary rock metamorphed, and it becomes a metamorphic rock. We know basically all this, and there's a lot of details in this which we study in geology, and that detail must be known. And this is very important part of engineering, civil engineering particularly, that without knowing good geological knowledge, without very good geological knowledge, we leave a lot to others and we don't have basis on that. Soil is very important part in engineering, construction, engineering design, same way as concrete. Concrete ultimately is a gas to soil. It means it goes to soil and soil takes care of this. So here we say construction is very complex world. Don't think that some foundation is done, some excavation is done, some column beams and other. Just people say, oh, column beam and this and that. Pillars or somebody call it, some lantern somebody calls it. That is only very small part of engineering. You may say just a part of engineering. Otherwise, engineering knowledge, it's not examination that you can be declared as engineer just by educational examination. It is in-depth knowledge you have, experience-based knowledge you have. That's what we say, practical engineer. Engineer who knows what to do, how to do, what is best. Here, all these activities which I am referring to relate to quality. It's not simply testing of material. It's not simply something like it has tension or compression or shear force and how we have to do it. It's not something that we have to see line work, plumb, likewise. All other activities that we can say in quality we have to hold. We have systems in quality, we call quality system. Quality system means everything should be covered in that. I'm not talking of international conditions where they say it is just for quality system. Quality system works, but does it work really? If system works, if you say system works, then every output, every product, every result should be qualitative, but practically you cannot see that. There may be many reasons behind that. Explanation is always available. Excuses are always available. But ultimate destiny is quantity that is qualitative. Quantity that is qualitative. If quantity is only quantity and you can say, okay, no problem, I could not get quality, I think you should not say no problem in that case. If you could not achieve quality, on what basis you say? On what basis you can get excuses? You can say, oh, there is this reason and that reason. That is not acceptable in real engineering. What I say, active quality performing application. What does it mean? I am saying active quality and not silent quality. You say we have quality system, but quality is not available. What does it mean? Product does not give quality when this product is produced in quality system. Now, how can you explain that ill situation of your system? If system does not get into quality product, it does not produce, it doesn't efficiently give quality, this means the system is not good one. System is not reliable one. We cannot just structurify system and say, this is my system, we comply by that, and that statement is not sufficient to justify quality product. If product fails even after systemized, this means it is all futile attempt. If system is right, if all resources work, if individuals work, everybody knows what to do, product should be in resonance to that. Active quality performing application is important. I am not saying passive quality. I am saying active quality, or you can say dynamism in quality. Dynamism in production is there, but dynamism in quality is important. Usually we work very fast. This is our production rate. We are very efficient in performance. We can meet our targets. But do we meet quality target? That is a point of concern. That's very much point of concern. Active quality performance. How do many people know what is active quality? Active quality means every time it should be in your mind to do it, to produce it, to achieve it. It's not easy. Active quality means, first of all, you have to be active. Engineer, contractor, whosoever comes into picture must be active. Workers should be active, supervisors should be active, machine operators should be active, machine should be active, resources should be active, method should be active. Means everyone should be alert and perform. Perform to level that is required. Not just keep in books only. For that, study is necessary. When we have projects, we have to refer to many documents. I am talking about those who work on construction. Particularly, when they do some construction work, this means we call it project, construction project. And we know that this is not forever. This project shall complete one day. It depends on durability, it depends on duration of contract duration. You have to be active during that duration. After that duration is over, after project is delivered, then project shall be active during operational duration, which is unlimited. Active quality performing application is very important. Every activity is operational. Every activity is application of decisions, application of methods, application of technology, application of, you can say, sciences. And with that, we say SHE, safety, health and environment. It's not valid alone for workers, it's valid for everybody. Whatever work we do, whatever structure we produce, whatever building we construct, they should be safe in use. Completely safe. If these are safe, users shall be safe, occupants shall be safe. If this building is good in health conditions, hygienic conditions, environment conditions, this shall provide pleasant living, pleasant occupation. It shall keep minds fit, healthy. And of course, when you don't have any problem, From that viewpoint of being healthy, being hygiene, being, pro-environment, you feel that your living environment, I'm not talking of air, I'm talking of your mind environment, pleasant, good, enjoying. And that's why I say we have to think of designs, we have to think of how designs are done, what actually do we expect. Maybe we don't understand total designs if we are not professionals. Our users, our occupants, or our promoters may not know what an engineer does, but once something is done, it can be used as an example or sample. Engineering approach on designs, manufacturing and construction is very, elementary to understand first, because we are talking approach, we are not talking destination. Approach roads, as we say, service road we can say, it's a kind of way to understand where we want to go. We want to go to engineering, we want to go to designs, we want to go to manufacturing, we want to go to construction. Everywhere approach is necessary, and that approach works with you. It's for you, it's for project. When we talk of quality, question arises, can we see quality? Can we see quality? That is one point. How to see quality? If you want to see quality, you have to meet quality. You have to go somewhere where the quality occupant resides. And that resides on projects, that resides in industries, that resides in factories, that resides on construction sites. Otherwise, where it is? You cannot construct something and say, okay, I am taking it with me, I am going to shop. That is not possible, particularly in construction. In products, mechanical products, other products, we can say, this product can be delivered to you at your doorstep. But construction products cannot be delivered to your doorsteps, because these are permanent projects, permanent materials, cannot be shifted in common. This means quality exists or it doesn't exist. It can be known only on project sites, nowhere else. If it exists, you can say this project is quality 1. We did lot of hard work on this as far as quality was concerned or is concerned, and this performing very well. So we can say in that case this building is quality structured. I am not saying finishes, I am particularly saying structures, because a structure is something exclusive. It is something that you cannot lift that from one place and fix conveniently at other place. It's very important part. This is having exclusive difference, exclusive, you can say, differentiation between smaller projects and construction projects. You may have hundreds of projects in the market, but you don't have any projects in structures. You may have structural steel, of course you may have, but that also depends on design or standards. So what I am saying is we have to see where quality exists, and we say that it doesn't exist automatically, it has to be worked upon. Or you may say it is not only ordinary quality, it is smart quality. Quality is very ordinary also, which we may not even identify or may not even consider. When it comes to volumes of material, volumes of product, where cubics and cubic meters and thousands cubic meters or millions cubic meters works are done, that is very important part. And its quality then that defines it. We can say earthwork is done. Earthwork is very simple term. We sometimes don't care for quality of work. We don't care for quality of soil, which is very much required to be known. Some people are very serious and some people are not serious. Both situations come up. If we are serious, then we have to be very serious And without that, no project can be completed, no construction can be done. Therefore, quality in every activity is important. As we have listed many times, many activities that are affected by presence or absence of quality system, quality performance. It's not only ordinary construction, it is quality performance. And that performance depends on what actually is defined on that project or specified on that project about controls. We have to define controls, we have to do controls. Otherwise, you cannot simply do something without having any particular objective in mind. What does quality exist? Where does it exist? This is not a question, in fact. And I can say I could not find this answer because this answer is not available. It's never available. You have to find your answer yourself. And there are, you can say, question then comes in, did you find it? Did you find it for deliberations? Your answer should be yes, I have smartness to respond to questions or queries. How I cannot do that? I am a quality person. I have experiences on such works, and those experience and knowledge or theory, whatever is there, I understand it. That's where you can say, that's what we can say, deliberations. You have to do. Quality deliberation is not so simple. You can deliberate only when you know what to do, how to do, where does it apply. That's very important point. As I said, red lines, it doesn't mean red color. No. It means something in question. Answer has to come. Every day I talk about this. But writing is one part and explanation is another part. When I say worsening state of quality, what does it mean? This means there should be quality. Quality may be defined. Quality may be defined for sake of documentation, but for sake of implementation, it's not cared for. It may be. But what I mean, what's happening, it doesn't tally with what's required. Irrespective of what sort of organization you have seen, people are same, workers are same, vendors are same, thoughts are same. Work culture depends on what sort of people you have in your group, your staffing personnel, what sort of control exists on works. Are they also serious? I don't want harassment also. If something has been done properly, it is to be accepted without any hitch. And if something has not been done, then it has to be done. It has to be done and modified. Nothing incorrect about that. But again question comes in, who shall question? Who has courage to question when everybody is having a mind not to talk of something because of conventions? But engineering doesn't accept that statement. Engineering says, I need quality. You have to achieve quality, or otherwise I am not engineering. I am just nothing. That is why quality is very, very significant, and I am not just dependent on quality system. I am dependent on quality achievement. You may write a long system, you may write job descriptions of all, you may write all ways to do, but if that is just in books, just in some company documents, and nobody bothers about that, then how can you achieve it? always we have to question these type of communications that we require, and then all designs related and coordination issues are required. It is a, you can say, kind of specified, or you can say specific, particular discipline, sub-discipline you may rather say, within engineering projects, within engineering itself, and of course in public. The communications and coordinations run together in life of everyone. Without these, we cannot even stand. We cannot claim anything. So, coordination, engineering, you may say, if you do not want to say only coordination, you can say it's branch of every engineering. Every engineering. Coordination is very technical in a way, as well as it's also non-technical in a way. It depends on which approach you have to apply coordination. Because coordination means everything, every act has been checked, every stage has been checked, there is no conflict, and we can very smoothly go on this activity and produce it. Coordination is that. It's not that inferiority or superiority, no. It's a pool of activities that should happen one time, or you can say simultaneously, for doing something important. That is coordination. And we have to do coordination according to one's capacity. Somebody, I have seen a very, very good people, very good engineers in coordination, and some people don't even understand how to coordinate. But when you say experience works with you, it gives you knowledge, and you should have caliber to coordinate. And that is also very important word, coordination. It means you have to know everything about what you have to do, and you have to find sources of that, you have to find technical requirement of that. If something is missing, you have to get it done. And that's what we say coordination. And coordination engineering is, you may say it is engineering, of course it is interdisciplinary engineering, it's not just one discipline engineering, it's civil electromechanical coordination, you may say electromechanical civil coordination, or you may say some other parts of that. Those coordination and coordinatory studies are very significant from every viewpoint. And then we can say what engineer should do. There's no definition as such. It depends on what project you are in and whatever your responsibilities. That is, is a kind of technology, coordination technology. And here it comes in role of engineer. Role of engineer, every level of engineer. Coordination is, it is for every project, smallest to biggest. And not only in construction project, it works elsewhere also. Coordination and construction are very significant requirements everywhere, and this must be properly done. And if you don't do properly done, you don't do it, means you have to suffer very badly. So it says, can we do it? Or we are incompetent, inconsistent societies and communities in engineering. So this question automatically is raised about coordination and all that. What is coordination? How it can be done? That's what we have to think about. And it's not in this talk I am doing, it's just general, and every time I talk, we are engineering force in our country. We have to be engineers, in fact, not just followers of somebody. There are so many texts on our head, we should not worry about them. Engineering, in fact, is very easy if you have complete information. You got my point. If you have complete information at localized place, you can say good engineering. Good engineering. Engineering is a concentration work. It's not speech in air. No. It's not just wall diagram. You are engineer because you are related to engineering. Otherwise, what's role? There will be many questions. Many questions. And people shall be raising these questions. Those questions cannot be answered in one go. You know, when we work on sites in civil engineering and construction engineering, you come abreast all disciplines, drawings, all disciplines. You may say now it is world of technology. We can automatically solve coordination problems according to BAMs or some other software. I don't trust that. Because it's not easy to understand first what we have to do. And if you understand that, then we apply to do it in different mode. Engineering is a wonderful world if it's respected that way. It's a wonderful world. It takes you to heights. It takes you from desert to cities. It takes you from ground to towers. It takes you to cupolas. It takes you from, foundations to whatever height you have. There is no one branch of engineering, and in every branch there are specializations. And whatever you're talking is very little. We are talking very little. And I know engineers are very serious, but engineers have to understand also something which doesn't relate to them. Learning drawings, making drawings is one part. Doing job according to real requirements is another part. That's why it's an important one. We say we do detailed derivations. What are those details? You can say, what about contracts for construction? Should engineers know thoroughly? Is that no question? Think so? Question is very easy. What about construction, contracts, and how much engineers know about that? Or for them, it's just a contract. They have to understand contract, meaning of contract. It's not just very small contract. Construction contracts are very long duration contracts. Maybe these work for years sometimes. So you can say a construction site is sometimes it's like home. It's like home for coming years. You can say construction site is like a home, maybe for 1 year for someone, for 2 years for someone. It depends. And we know that there are always availability of workers around who are involved on that project, and generally they live around, so that site also becomes home for them for some period. This means so many activities are involved. That's why so many people are there. It's not just small item we produce. We produce small items, we produce very major items. This happens. We should not run away from that fact. We should not run away from that fact. Contracts, a very tough document. Tough means in strength, or you may say powerful document. Powerful. Because it empowers both. Contract empowers both. Both means what? It empowers whoever parties are defined or named on that contract. Contract is very powerful document. It has strength, it has capacity, it has total potential because it is well defined. And if contract is well not defined, it's not well defined, you can say it's unwell, it's incomplete, and we say no, it is complete. There's always difference of opinion. Contract, an experienced engineer, an experienced one, and a new one, both have different opinions about contract. But one point must be clear to everyone, that contract is not a joke. It's not a joke. Okay, we sign and we'll see later on. We cannot say that. Today we sign for sake of just signing, and we will review it after 5 months or 6 months. That is also not right. That cannot happen. Contract is very decisive document. Very decisive. It's very powerful because this contract, if it's honored properly, it performs properly, it has to deliver product of building, structures, whatever, and it impacts our lifetime earnings. I'm talking for very common one. Therefore, contract is in interest of owner. Contract is also in interest of contractor. And when contract exists means all detailed necessary conditions exist, which we can call general or we can call particular conditions, or we can say gross particular conditions. It's very serious issue. Contract. I have seen many engineers can write excellent to an extent contract is concerned. If they cannot do something in writing based on what they think, how can you communicate something to be done this way? You see, just giving a speech is not enough. Professional speech, if you give in some meeting or somewhere else, then you ask questions on that. If people are serious, they listen to what you say, can easily scribe or write, you know it. That's a point of concern. Contracts should not be misunderstood. We should not misunderstand contract, because contract means something has to be done, what is described in that. Whatever is included in that contract has many vistas. We have to understand contract first. It may be contractor, it may be owner, or it may be whosoever. We have to understand whether proper communication exists or it doesn't exist. It's a very important point. We cannot blindly move on contract, and if we keep changing during tender or some other time, I don't think it will be in the interest of anybody. Contract is very important item. If we do not know work, how work shall be done, what shall be problems before work and after work is done, we cannot constitute a contract. It's a constitution. Contract is a kind of charter. It's a constitution, particularly for that project. And this constitution is agreed by both parties. These parties know how much they have to spend and how much they have to come into business with. It's very important part. And if we don't understand quality of contract, you cannot understand anything. It's not simple document. It's a document that has to give responsibility credit to whosoever are involved in this operation. It's not that I can complete this discussion all time. If you understand quality system, you have to understand all other systems as well. Quality system, you may say environment system, or you can say construction system, design system, whatever is expected. If we are educated, of course we are, not all, but at least 25%. And other 25% are only those who work somewhere without even use of these technical words. This means we are very clear. And we have to apply this knowledge with very decisive mind. When you do designs or when you do construction, we have to be very serious in understanding everything. We cannot just do something without even referring to documents and later on say, oh, it happens, no problem, I didn't study the document. If some engineer says that, how do you expect that engineer should be matured enough? That's why I say there's a long discussion on this, and we'll keep every day. We cannot move text and show. We have to respect. We have to respect projects quality. We have to respect time. We have to respect provisions on contract data, because we produce that. We produce that. No one else. We have to go to other file also, because we cannot take full time on this. We have to go to other files as well, and that is very important file, and that is concrete terminology, where we had gone full, and there were some points that I think it was 70 page. It is temperature rise, temperature stress, temperature rise period, temperature time factor, template, temporary stress, tendon, likewise. We discussed something last time and we discuss again. It's not that this 70 page of 80 or is going to finish. I'm not interested in just running very fast to finish it, because finishing is not required, understanding is required. We have to understand what is there, how it is there. That's very crucial. We have to be very practical in this regard. And let me see temperature. What's the station now? Because I'm feeling very cold. It's now. Let me see what temperature is. I don't know if I'm sick or what's happening. It's in 10 degrees. Dew point it's showing is dew point is 9 degrees. So humidity is 97%. That's problem here. 97% humidity at this moment. So this temperature 10 doesn't mean 10. It means maybe 5 or 4 because of humidity. And cloud cover is 40%. This means 60% is not covered. And the height of cloud ceiling is 12.2 kilometers. So it's really different. You can say in day it's 19 degrees expected, and at night maybe 9 degrees, and expectation of rain at night. No problem. Just we thought of this in one way or other, and we thought of what to do with this, what to do, and because I was not feeling well. But I have to continue this talk. I don't want to just jump down and also there's some news here. Supreme Court extends women's right to parents' property prior to 56. Okay, this is good one. And also here you can say right, just a minute please. Let's continue our talk. A waste of time, no use. My dear, then I go on to this and say what's temperature rise. Says increase of temperature caused by either absorption of heat or internal generation of heat. Temperature rise, that is increase of temperature caused by either absorption of heat, when you absorb heat, or you can say internal generation of heat, or you can say hydration of cement and concrete that gives rise to temperature. So definition very clear, it is very common definition, very clear definition. Temperature rise, that increase of temperature caused by either absorption of heat or internal generation of heat, for example hydration of cement and concrete. And of course temperature stress, it says stress in a restrained structure, or it says stress in a restrained structure or a member due to changes of or differentials in temperature in structure or member. So temperature stress, one is temperature rise. Temperature rise happens when there is increase in temperature, which can happen because either of the absorption of heat or internal generation of heat, both ways. You can take heat from weather, or you can have chemical reaction based heat, or that's heat of hydration. And then there can be stresses. There's a stress in restrained structure. Restrained structure says not free structure. Remember, due to changes or differentials in temperature in structure or remember. And says temperature rise period, that is time interval during which temperature of concrete product rises at a controlled rate to desired maximum in autoclave or atmospheric pressure stream curing. Very important point, temperature rise period. It says about that temperature rise period, that is atmospheric pressure, steam curing or autoclave. Temperature time factor, that is product of temperature multiplied by time for a spatial interval. What is template? I'm sorry. Template is a thin plate or board frame that is used as a guide in position or spacing from parts. Reinforcement or anchors, you can say a thin plate or board frame used as a guide in positioning or spacing from parts. Reinforcement or anchors, or you can say a full-size mold, pattern or frame. A full-size mold, pattern or frame shaped to serve as a guide in forming or testing contour or shape. A full-size mold, pattern or frame shaped to serve as a guide in forming or testing. We say temporary stress. Says stresses that may be produced in precast concrete member or in a component of precast concrete member during fabrication or erection, or in cast in place concrete structures due to construction or test loading. These are temporary stress, it says. Tendon, well, is an assembly consisting of tensioned elements such as wire, bar, rod, strand, or a bundle of these elements used to impart compressive stress, in concrete, along with whatever associated components used to enclose and anchor tension elements. Tendon profile, path or trajectory of pre-stressing tendon. Path or trajectory of pre-stressing tendon. Tensile strain capacity. Maximum tensile strain that hardened concrete paste, mortar or concrete can sustain before cracking occurs. Tensile strain capacity is maximum tensile strain that hardened cement paste, mortar or concrete can sustain before cracking occurs. Tensile strain limit, you may say, or capacity, you may say. Then tensile strength, maximum, you can say, stress that a material is capable of resisting under axial tensile loading based maximum stress. We are talking of tensile strength. Maximum stress that a material is capable of resisting under axial tensile loading based on cross-sectional area of specimen before loading. Tension reinforcement. Reinforcement designed to carry tensile stresses such as those in bottom of simple beam. Reinforcement designed to carry tensile stresses such as those in bottom of simple beam is very elementary. Ternary mixture. Concrete containing three cementitious materials. Three cementitious materials is ternary mixture. So, like we use cement, we can use PFA, or we can use GGBS, or we can use microsilica. Three cementing materials we use that can be called ternary mixture. There is a concrete, it's called concrete though, it's not concrete, whereas the concrete of called terrazzo concrete means marble aggregate. Marble is metamorphic rock, marble aggregate, concrete, marble aggregate concrete that is cast in place or precast and ground smooth for decorative surfacing purpose on floors and walls. And test is a trial, examination, observation or evaluation used as means of measuring. This is trial. So many stages are there. Either a physical or a chemical characteristic. Either a physical or a chemical characteristic of a material, or a physical characteristics of either a structural element or a structure. A trial, how to define it? Test, a trial, examination, observation or evaluation of a material or a physical characteristic of either a structural Mineral element or a structure. Tetra calcium aluminoferrite. Tetra calcium aluminoferrite. The name is long. Tetra calcium aluminoferrite. And you know, tetra stands for 4 approximately. We say tetra, not territory, and you can see then a compound in calcium, calcium aluminoferrite series. Calcium aluminide series, that is because tetra calcium aluminoferrite. This is a compound in calcium aluminoferrite series having composition 4 CaO. 4 indicates that I have 4 CaO, Al2O3, that is aluminoferrite, alumino, and this is Fe2O3. Now we abbreviated C4AF, aluminoferrite, and C4 tetra calcium. It's just, abbreviation is C4 stands for, C stands for calcium and 4 tetra, A stands for alumino, and ferrite is F, C4AF. That is usually assumed to be aluminoferrite present. Aluminoferrite present when compound calculations are made from results of chemical analysis of Portland cement. Usually assumed to be aluminoferrite present when compound calculations are made from results of chemical analysis of Portland cement. It's also referred as brown millerite. Now what is texture? Texture is very easy word. A kind of, you can say, repetition on something. Texture, not plain. Something is there, and that is pattern. Pattern or configuration. Pattern or configuration apparent in an exposed surface. Apparent in an exposed surface, as in concrete and mortar, including roughness, striking, striation, or departure from flatness. I repeat it, it's a pattern. Texture is a pattern, or it's a configuration on exposed surface. Exposed surface, configuration on exposed surface. It is a configuration on exposed surface, as in concrete and mortar, and it includes roughness, striking, striation, or departure from flatness. Now texturing, we say it was texture or texturing is process of producing a special texture on either unhardened or hardened concrete both. Texture it. Thermal conductance. Thermal, is heat related. Thermal conductance. Conductance, we can say, of a gas, liquid, or solid. Measure of rate at which heat passes perpendicularly through a unit area of material of specified thickness for a temporary difference of 1 degree. Very easy definition. It says rate at which heat passes perpendicularly through a unit area of material of specified thickness for a temperature difference of 1 degree. For a temperature different of 1 degrees, what heat is passed, that is gas, liquid or solid, whatever, rate at which heat passes perpendicularly through a unit area of a specified thickness for a temperature difference of 1 degree. That was thermal conductance. Now we come to thermal conductivity. Thermal conductivity. You may say ability of a homogeneous material to conduct heat. Ability of a homogeneous material to conduct heat measured as steady state heat. Ability of a homogeneous material to conduct heat measured as steady state heat flow per unit area through body of unit thickness with 1 degree temperature difference between surfaces. Thermal contraction. Contraction caused by decrease in temperature. Thermal contraction. Contraction caused by decrease in temperature. Contract means, it's not contract that contract, it is contraction, means reduction. You can say contraction caused by decrease in temperature. And something is cooler, you can say it may contract. And something is heated, it may expand. So it is reversal. Expansion means it is contraction. Contraction caused by decrease in temperature, or you can say it's very cold and we shiver like that. That kind of, we say, oh, I'm frozen, it's frozen, I'm frozen. It's a contraction. Thermal diffusivity. Diffusivity, it's like conductivity, thermal conductivity divided by product of specific heat and density. That is thermal conductivity and diffusivity, how much thermal heat energy is diffused, and that's what says how much energy is diffused. Thermal diffusivity, thermal conductivity versus conducted, that quantity is divided by specific heat into density. Specific heat into density. So we can say you can get thermal diffusivity. Now, an index of ease with which a material undergoes temperature change. Index of ease which a material undergoes temperature change means if material can digest temperature change, you may say it is like diffusivity, means to which extent it can digest that or it can tolerate that temperature change. Then we have thermal expansion that is caused by increase in temperature, as we discussed before. Decrease in temperature, which is contraction, it's expansion caused by increase in temperature. That is whatever increases there, and you can say it expands. And then it may be expanding or maybe contracting. This is movement, thermal movement. You can say change of dimension because of this contraction or expansion. The chances that change of dimension of concrete or masonry resulting from change of temperatures. So whatever dimension is affected, it can be called change, and it is in concrete or masonry, results from change of temperature, or you can say change of thermal contraction and thermal expansion, and that is called movement, thermal movement. Means then we have resistance, thermal resistance, which is reciprocal of conductance, means how much heat it resists that is reciprocal of thermal conductance expressed by symbol R. So that is conductance. Reversal thermal resistance is just like in electrical we say electrical conductance, and likewise thermal shock, heat shock you can say. Subjection of newly hardened concrete to a rapid change in temperature, that is thermal shock. If you subject hardened concrete, new one, to rapid change in temperature, you can say it is temperature stress or thermal shock. Now, thermal volume change. See, these are very important definitions. We have to understand this before going into jumping into learning more and more, because if definitions are clear, if elementary bases are not clear, it's difficult always to understand terms. And here we say thermal volume change. What is thermal volume change? It says thermal volume, remember, increase or decrease in volume because of thermal change. Increase or decrease in volume caused by changes in temperature. Very simple, and that is we have to refer related to thermal contraction, thermal expansion. There may be volumetric increase or volumetric decrease, and that is volume change related to thermal energy. And then thermoplastic, very common term. It is common, and this is repeatedly, you can say, repeat softness. If you heat something, if you heat some material, it shall soften, right? It shall soften if capable of being repeatedly softened by heating and hardened by cooling. It's very common. If you heat something, it shall of course melt, and that can be called softening. And if you cool it, if you withdraw heat from this, cool it, it shall become, hardened. So that's thermoplastic, means hardening stays or softening stays. The property of plastic, but not exactly hydrocarbons I'm talking. Now, thermosetting. There's chemical reaction and not remeltable. It's like, we say thermal change, or you can say chemical change in chemistry. So thermosetting means rigid becoming rigid by chemical reaction and not remeltable. If it is like that, cannot remelt it. Thin shell precast. Precast concrete characterized by thin slabs and web sections. Thixotropy. This is very important term, particularly in clay soil also. Clay soil, which we say Montmorillonite, it's also a very important term. Thixotropy is a property of material to thin up or to be thin up, isothermal, thin upon isothermal agitation. A property of material to become thin, upon isothermal agitation, and to thicken upon subsequent rest. Or you can say to make it thinner, if isothermal expansion agitation applies, and it shall become a little thicker if subsequent rest. So that is thixotropy. We explained last time what is that. Particularly it happens that it's particularly in clay mode, you can say Threaded not encourage, threaded encourage. Threaded encourage. Anchorage device that is provided with threads. Making it threaded, not thread, T-H-E-R-E, thread. Threaded to anchorage. Sorry that I'm feeling little uneasy today. I don't know the reason behind that. Let me put this like this so that I take out. I switch off my battery for a while because I forgot it's recharged. That also. It's don't know what's happening. So we can say that I was there on threaded anchorage, yes. Anchorage device that is provided with threads to facilitate attaching jacking device. To facilitate attaching jacking device and to effect anchorage. Tie loop of reinforcement bars, loop of reinforcing bars and circling longitudinal steel columns and tensile unit adapted to hold concrete forms, that is tie vault ties, you can say, no, not vault ties, actually tie bolts, as tensile unit adapted to holding concrete forms, that is secure against lateral pressure of unhardened concrete, that's split concrete, a tension member in a strut and tie model. And you know tie bar, as I discussed, bar at right angles to and tied to reinforcement to keep it in place. That is bar at right angles to and tied to reinforcement to keep it in place. Tie rod, that's the same tie, form tie and tie back. And tie back a rod, tie back, it's different, tie back. Tie back a rod fastened to a dead man. Tie back a rod fastened to a dead man, a rigid foundation or either a rock or soil, anchor to prevent lateral movement of formwork, sheet pile walls, retaining walls and bulkheads. Tie back a rod, tie back, it's again tie back means a rod fastened to dead man, a rigid foundation or either a rock or soil anchor to prevent lateral movement of formwork, sheet pile, walls, retaining walls and bulkheads. Here also we have a tied column, a column laterally reinforced with ties. Tied column, a column laterally reinforced with ties. A column laterally reinforced with ties, and that's called tied column. Tilting mixer. You know, is mixer means a revolving drum mixer that discharges by tilting drum about a fixed or movable horizontal axis at right angles to drum axis. Drum axis may be horizontal or inclined while charging and mixing. That is tilting mixer, revolving drum mixer, revolving drum mixer that discharges by tilting drum about a fixed or movable horizontal axis at right angles to drum axis. Drum axis may be horizontal or inclined while charging and mixing. Tilt up. Tilt up, a construction technique for casting concrete elements in a horizontal position at job site and then tilting them to their final position in a structure. A construction technique for casting concrete elements in a horizontal position at job site and then tilting them to their final position in a structure. Time of haul. Time of haul. In production of ready-mix concrete, period from first contact between mixing water and cement until completion of discharge of freshly mixed concrete. Time of haul. And time of setting. Time required for a freshly mixed cement paste, mortar or concrete to achieve initial setting. Time required for a freshly mixed cement paste, mortar or concrete to achieve final set. Time of setting. Time dependent deformation. Time dependent deformation. Deformation resulting from effects such as autogenous volume change. Time dependent deformation. Deformation resulting from effects such as autogenous volume change, thermal contraction or expansion, creep, shrinkage and swelling, each of which is function of time. Time dependent deformation. Tober-Morite gel. Tober, T-O-B-E-R, Tober-Morite gel. Something new, I think. Binder of concrete. Binder of concrete cured moist. Binder of concrete cured moist or in atmospheric pressure steam. Binder of concrete cured moist or in atmospheric pressure steam. A lime-rich gel like solid containing 1.5 to 1 moles of lime per mole of silica. 1.5 to 1 mole of lime per mole of silica. That is gel like solid containing 1.5 to 1 moles of lime per moles of silica. I repeat, that is binder of concrete cured moist or in atmospheric pressure steam. A lime rich gel like solid containing 1.5 to 1 mole of lime per mole of silica. And tolerance is permitted deviation from a specified dimension, location or quantity. Permitted deviation from a specified dimension, location or quantity. Then tongue and groove. Tongue and groove, a joint in which a protruding lip on edge of one side fits into a groove. A protruding lip on edge of one side fits into a groove in edge of other side. This is abbreviated as TNG. Tooling. Tooling is act of compacting. Tooling is act of compacting and contouring. Act of contouring material in joint. Act of compacting and contouring material in a joint. Act of compacting and contouring a material in a joint. Act of compacting and contouring a material in a joint. Top form. Top form. Form required on upper or outer surface. Form required on upper or outer surface of a sloping slab. Form required on upper and outer surface of a sloping slab or a thin shell. Topping, a layer of concrete or mortar placed to form a floor surface. A layer of concrete or mortar placed to form a floor surface on a concrete base. Or structural cast in place surface for precast floor or roofing system. Mixture of marble chips and matrix that, when properly processed, produces a terrace surface. Torque viscometer. Torque viscometer. This is an apparatus used to measure consistency of slurries. Torque viscometer is an apparatus used for measuring consistency of slurries, in which energy required to rotate a device suspended in rotating cup is proportional to viscosity. Let us repeat this. Torque viscometer. Viscometer measuring is apparatus used in measuring consistency of slurries, in which energy required to rotate okay. We may say that apparatus used for measuring consistency of slurries, in which energy required to rotate a device suspended in a rotating cup is proportional to viscosity. Torsional stress, shear stress on a transverse cross section. Shear stress on a transverse cross section resulting from twisting action, that is torsional stress. Stress shear stress on a transfer section. We have now and say torsional stress, shear stress on a transverse cross section resulting from a twisting action and toughness, ability of material to absorb energy without rupturing, ability of a material to absorb energy without rupturing, amount of energy per unit volume of material to rupture material. And we can say other one is transfer to shift tensioning force for a strand, tensioning force for a strand or strands from a jack or pre-tensioning bed to a concrete or masonry chamber. Shift tensioning force for a strand or strands from a jack to shift tensioning force for a strands or strands from a jack or pre-tensioning bed to a concrete or masonry member. Transfer bond. Transfer bond. Transfer bond, we can say. What is transfer bond? In pre-tensioning, bond is stress. Bond is stress resulting from transfer of stress from tendon to concrete. That is transfer bond. Pre-tensioning bond stress resulting from transfer of stress from tendon to concrete. Transfer length. Transfer length. I am not feeling well. What's happening? Transfer length. Transfer length is length from end of member where tendon stress is 0. Tendon stress is 0 to point along tendon where pre-stress is fully effective. Transfer length. Length from end of member where tendon of stress, where tendon stress is 0 to point along tendon where pre-stress is fully effective. That is transfer length. Transfer strength. Transfer strength. Concrete strength. Concrete strength required before stress. Concrete strength required before stress is transferred from stressing mechanism to concrete. That is transfer strength. Strength in concrete required before stress is transferred from stressing mechanism to concrete. Transit mixer, struck mixer, nothing big. Transit mixed concrete. Transit mixed concrete. Transit mixed concrete. Concrete that is mixed totally. Concrete that is mixed totally or mostly in a truck mixer. We call it transit mixed concrete. Means concrete that is mixed totally or mostly in truck mixer. Translucent concrete. A combination of glass and concrete used together in precast and pre-stressed panels. A combination of glass and concrete used together in pre-stressed panel. Translucent concrete. Translucent concrete, then transmission length. Transfer length is same as we discussed before. Transverse crack. Transverse crack. A crack that occurs. A crack that occurs across longer dimension in all concrete. So we can say transverse crack, a crack that occurs across longer dimension of member. Transverse crack, a crack that occurs across longer dimension of member. Transverse joint, a joint normal to longitudinal dimension of a structural element, assembly of elements, slab or structure. We can say transverse joint, a joint normal to longitudinal dimension of a structural element, assembly of elements, slab or structure. Transverse pre-stress, pre-stress that is applied at right angles to longitudinal axis or to S. Transverse pre-stress, pre-stress that is applied at right angles to longitudinal axis of a member. Transverse pre-stress, pre-stress that is applied at right angles to longitudinal axis of a member or slab. Transverse reinforcement, reinforcement at right angles to longitudinal reinforcement. Transverse strength, flexural strength, and modulus of rupture. Flexural strength and modulus of rupture. This is trap rock. Trap rock. Then we can say a little, transverse strength, flexural strength, modulus of rupture. Trap rock. Trap rock. Various fine-grained, various fine-grained, dense, dark-colored, igneous rocks. Uh, you can say trap rock. I'm sorry, little disturbance because of my health. I'm not feeling well anyway, but I'll end up so something as much as I can do. I'm feeling unwell. Trap rock, many various fine-grained, dense, dark-colored regions. Igneous rocks, I can say various fine-grained, dense, dark-colored igneous rocks, so typically basalts or diabase, called trap. That is basalts or diabase, and Basalts, these are available generally at sea bottom, sea base, and you can say basalts rock. Here it's a fine grained, very fine grained, dense, and grained up on there. Yes. So you have to see this very, very seriously. That is traveler, inverted U-shaped structure. Traveler is inverted U-shaped structure, usually mounted on tracks on that permit it to move from one location to another to facilitate construction of an arch, bridge or building. That is traveler, inverted U-shaped structure, usually mounted on tracks that permit its movement from one location to another to facilitate construction of an arch, bridge or building. Travertine, close to irregularity, close to regularity, you can say regularly porous, present in even projection. You can see then trimming. Trimming is a pipe. Trimming is a pipe. It's a very important item. Trimming is a pipe that is trimming pipe extending below water, generally with a funnel-shaped top, funnel-shaped top through which concrete can be deposited. Pipe extending below water, generally with a funnel-shaped top, embedded in a fresh concrete that is being placed. Layer of traffic concrete placed in cofferdam for purpose of preventing intrusion of water when cofferdam is dewatered. It says that it's very easy when cofferdam is dewatered. Trench form, vertical sides and semi-circular bottom of a trench. Vertical sides and semi-circular bottom of a trench, excavated through compacted soil to provide exterior form, and base for a cast in place concrete pipe. Vertical sides, semicircular bottom of a trench excavated through compacted soil to provide exterior form and base for a cast in place concrete pipe. Trial batch, a batch of concrete prepared to establish acceptable proportions of constituents. Triaxial compression test, a test in which a specimen is subjected to a confining hydrostatic pressure and then loaded axially to failure. Triaxial compression test, a test in which specimen is subject to confining hydrostatic pressure and then loaded axially to failure, and that is triaxial test. Triaxial test, a test triaxial test, that is test in which a triaxial compression test, a test in which a specimen is subjected to a confining hydrostatic pressure and then loaded axially to failure. Triaxial test, a test in which a specimen is subjected simultaneously lateral and axial loads. We have here tricalcium aluminate, a compound having composition 3CaOAl2O3, as we say, abbreviated C3A. Tricalcium aluminate silicate, tricalcium silicate, that is C3S, compound having composition 3CaO SiO2, abbreviated C3S, an impure form of which is main constituent of Portland cement. Trough mixer, open top mixer. Trowel, a flat, broad blade steel hand tool used in final stages of finishing operations to impart a relatively smooth surface to concrete floors and other unformed concrete surfaces. A flat, triangular blade tool, used for applying mortar A flat, broad blade steel hand tool used to place, spread, shape, finish or otherwise apply materials. Travel finish, a smooth finish of an unformed concrete surface obtained by traveling. Traveling is moving and compacting unformed surface of fresh concrete by strokes of a trowel. Troweling machine, a motor driven troweling machine, a motor driven device that operates orbiting steel trowels, a motor driven device that operates orbiting steel trowels on radial arms from a vertical shaft. Troweling machine, a motor driven device that operates orbiting steel trowels on radial arms from a vertical shaft. Truck mixer, a concrete mixer suitable for mounting on a truck, chassis and capable of mixing concrete in transit. Then we have, in this case, truck mixed concrete, transit mixed concrete, and T-shore is shore with T-head. Tub mixer, C open top mixer, tube and coupler shoring, load carrying assembly of tubing, load carrying assembly of tubing or pipe that serves as posts, braces and ties, a base supporting posts and special couplers that connect uprights and join various members. Tube and coupler shoring. Now, tunnel lining, a structural system of concrete, steel or other materials to provide support for a tunnel for exterior loads, to reduce water seepage or to increase flow capacity. Tunnel lining, a structural system of concrete, steel or other materials to provide support for a tunnel for exterior loads, to reduce water seepage or to increase flow capacity. Turbidometer, device for measuring particle size distribution of a finely divided material by taking successive measurements of turbidity of a suspension in fluid. Turbidometer, a device for measuring particle size distribution of finely divided materials by taking successive measurements of turbidity of a suspension in a fluid. Turbidimeter fineness of material such as Portland cement, usually expressed as total surface area in square centimeters per gram, as determined with the turbidimeter. Turbine mixer, turbine mixer, C open top mixer, then twin twisted bar reinforcement. Twin twisted bar reinforcement. Two bars of same nominal diameter twisted together. Twisted steel micro rebar. Twisted steel micro rebar, TSMR. TSMR, twisted steel micro rebar. A steel rod or wire with non-circular section. Non-circular section twisted at least one time. 360 degrees. About its own axis. So this is twisted steel bar reinforcement, and twisted steel micro rebar, a steel rod or wire with non-circular section, twisted at least one time, 360 degrees about its own axis, using or used as discontinuous reinforcement. Discontinuous reinforcement. Product is typically small enough to be mixed in large numbers into concrete before placement. Used as discontinuous reinforcement. Product is typically small enough to be mixed in large numbers into concrete before placement. Twisted steel micro rebar. Twisted steel like steel rod or wire with a non-circular section, twisted at least one time, 360 degrees. About its own axis, used as discontinuous reinforcement. Product is typically small enough to be mixed in large numbers into concrete before placement. Two-way reinforced footing. A footing having reinforcement in two directions, generally perpendicular to each other. Two-way reinforcement, two-way. Two-way reinforcement. Reinforcement arranged in bands of bars at right angles to each other. Two-way system of reinforcement, that is bars, rods or wires placed at right angles to each other in a slab intended to resist stresses due to bending of slab in two directions. Type 1 cement. Type 1 cement is normal cement. Of course, normal cement. You may say OPC. Type 2 cement is modified cement. Type 1 is normal, type 2 is modified. Type 3 is high early strength cement. High early strength cement, and type 4 is low heat cement. So number 1 is normal, number 2 is modified, number 3 is high early strength, number 4 is low heat cement, number 5 is sulfate resistance cement. So normal is type 1, modified is type 2, early strength is type 3, low heat is type 4, and sulfate resistant is type 5. Type 1 is normal cement, and Type 2 is modified. Type 3 is we have then I5 cements are there. Type 1 is normal, type 2 is modified, type 3 is higher strength, and type 4 is low heat, and type 5 SRC. Ultimate load, maximum load that may be placed on a structure or a structural element before its failure. Ultimate load, maximum load that may be placed on a structure or loaded. See, it is, it represents maximum load that may be placed on a structure or structural element before its failure. Ultimate moments, and that's same. Ultimate shear, same. Nominal flexural strength, nominal shear strength, and ultimate shear stress. Ultimate strength, maximum stress developed in a specific area. We have here, you can say, go further, here is ultimate shear stress, we have shear strength, ultimate strength, maximum stress development specimen, ultimate strength design method, and ultimate tensile strength UTS. Ultimate tensile strength of a fiber reinforcement, the concrete, small, simple under. Then we have here this is ultimate tensile strength, that is ultimate tensile strength of fiber reinforced concrete sample under uniaxial tension. Ultra high performance concrete. Yes, that's a very important point. Concrete that has minimum specified compressive strength of 150 MPa. High performance concrete that has minimum specified compressive strength of 150 MPa with specified durability, tensile ductility, and toughness requirements. Fibers are generally included to achieve specified requirements, that is ultra high performing concrete that has a minimum So this is ultra high performance stone concrete, that is 150 MPa, and ultrasonic. Ultrasonic is, you can say, in this MPA with specified durability, tensile, ductility and toughness requirements, fibers are generally included to achieve specified requirements, and ultrasonic is pertaining to mechanical vibrations having a frequency greater than 20,000 Hz. Ultrasonic, that is pertaining to mechanical vibration having a frequency greater than approximately 20,000 Hz. Unbonded member, pre-stress concrete, member post-tensioned with tendons that are not bonded to concrete between end anchorages after stressing. Unbonded post-tensioning in which tendons are not grouted after stressing. Unbonded tendons that is permanently prevented from bonding to concrete after stressing. Unbraced length of column, distance between lateral supports. Unbraced length of column and under bed. Base mortar usually horizontal. Into which stirrups are embedded and on which terrazzo topping is applied. Undersanded concrete containing an insufficient proportion of fine aggregate. Concrete containing an insufficient proportion of fine aggregate to produce optimum properties in fresh mixture. Is understood? Concrete containing an insufficient proportion of fine aggregate to produce optimum properties in fresh mixture, especially workability and finishing characteristics. Undersize particles of aggregate passing a designation sieve. Underwater concrete, concrete placed underwater by TREMI or other means. Unhardened concrete, fresh concrete, unit masonry, a construction element consisting of masonry unit. A construction elements consisting of masonry units. Unit water content. Quantity of water per unit volume of freshly mixed concrete, excluding water absorbed by aggregate. Then we have here unit water content, quantity of water per unit volume of freshly mixed concrete, excluding water absorbed by aggregate. Unit weight is density, unreinforced concrete, plain concrete, unsound, not firmly made, placed or fixed, subject to deterioration or disintegration during service exposure. What is U value? Overall efficiency. overall coefficient of heat transmissibility, let's say U value. U value is overall coefficient of heat transmission. Overall efficiency, overall coefficient of heat transmission, a standard measure of rate at which heat flows through a unit area of a material of known thickness. Overall coefficient of heat transmission, a standard measure of rate at which heat flows through a unit area of material of known thickness. That is, you can say thermo U value transmission of heat through the material. Conductance, you can say thermoconductance, right? And vacuum concrete, concrete from which excess water and entrapped air are extracted by a vacuum pressure before setting occurs. Concrete from which, vacuum concrete it is, and concrete from which excess water and entrapped air are extracted by a vacuum process before setting occurs. That is vacuum concrete from which excess water and entrapped air are extracted by a vacuum process before setting occurs. We have then vacuum dewatering, vacuum concrete, vacuum saturation, a process for increasing moisture content of lightweight aggregate. Vacuum saturation, a process for increasing moisture content of lightweight aggregate by subjecting it to a vacuum in a sealed chamber, flooding chamber with water and releasing vacuum. That we can say vacuum saturation, a process for increasing moisture content of lightweight aggregate by subjecting it to vacuum in sealed chamber, flooding chamber with water and releasing vacuum. Valve bag, paper bag for cement or other material, either glued or sewn, made of 4 or 5 plies of craft paper and completely closed except for a self-sealing paper. Okay, then we have vapor barrier, that is what we said, well bag, paper bag for cement or the material, either glued or sealed, made of 4 or 5 plies, craft paper and completely closed except for a self-sealing paper valve through which contents are introduced and released. Vapor barrier membrane located under concrete floor slab. So this snail corners. We have vapor barrier and vapor pressure rating. Pressure was vapor pressure. Then pressure exerted when a vapor is equilibrium. Vapor pressure exerted when a vapor is in equilibrium with its liquid or solid form at a given temperature. Vapor retarder. Vapor retarder, a membrane that impedes transmission of gas molecule. A vapor retarder, that is membrane that impedes transmission of gas molecules. Webby apparatus, WEBE, Webby apparatus of then we have here, you can say something else, you can say here 39 minutes percentages we have here. Say web apparatus you have seen, and that is an apparatus for measuring workability of very low, an apparatus for measuring workability of very low slump or no slump. That's a web apparatus. That's concrete, including a vibrating table, a simple container, and a road. We have to see vehicle. Vehicle can say that is once again VB practice and practice for measuring workability of very you can say slow slump, low slump or no slump. Concrete including a variable table, a sample container and other ancillary items that permit measurement of slump. So that is this permits measurement of time required to consolidate it in a mold through the consolidation in the purpose for measuring workability of very low slump or no slump concrete, including a vibrating table, where the time required to consolidate will be consolidated in a mold. Required to be consolidated in a mold and the vehicle liquid carrier or binder of solids, liquid carrier or binder of solids, Wiener, a masonry facing that is attached to backup but not so bonded as to act with under load. Venetian type of terrazzo topping, Venetian a type of terrazzo topping that incorporates large chips of stone. Venetian type of terrazzo topping that incorporates large chips of stone. Venetian vermiculite, a micaceous metal. A vapor retarder, a member that impedes transmission of gas molecules. Vermiculite, a micaceous mineral. Vermiculite, a micaceous mineral. A micaceous mineral, a group name for certain platy materials. A micaceous mineral, a group name for certain platy minerals. Hydrous silicate of aluminum, magnesium, and iron, characterized by marked exfoliation on heating. Constituent of clays, vermiculite. One is micaceous mineral, other one is group name for certain platy minerals. Hydrous silicates of aluminum, magnesium, and iron, characterized by marked exfoliation on heating. A constituent of clay, vertical shaft mixer, cylindrical or annular mixing compartment having an essentially level floor and containing one or more vertical rotating shafts to which blades or paddles are attached. Mixing compartment may be stationary or rotating or rotate about vertical axis. Vibrated concrete. Vibrated concrete. This is vibrated concrete. Concrete consolidated by vibration during and after placing. Vibration is, what is vibration? Vibration, energetic agitation. Vibration is energetic agitation of freshly mixed concrete during placement by mechanical devices, either pneumatic or electric, that create vibratory impulses of moderately high frequency to assist in consolidating concrete in form or mold. This is for vibrated concrete. That concrete is consolidated by vibration. We call it compaction by vibration during and after placing. Vibration is, that is, energetic agitation of freshly mixed concrete. Energetic agitation of freshly mixed concrete during placement. Energetic agitation of freshly mixed concrete during placement by mechanical devices, either pneumatic or electric, that create vibratory impulses of moderately high frequency to assist in consolidating concrete in form or mold. External vibration and internal vibration. External vibration employs vibrating devices attached at strategic positions on forms and is particularly applicable to manufacture of precast items and for vibration of tunnel lining forms. Tunnel lining forms. In manufacture of concrete products, external vibration or impact may be applied to casting table. Internal vibration employs one or more vibrating elements that can be inserted into fresh concrete at selected locations and is more generally applicable to in-place construction. Surface vibration implies a portable horizontal platform on which a vibrating element is mounted. Vibration limit. Age at which fresh concrete has undergone a sufficient degree of setting. Age at which fresh concrete has undergone a sufficient degree of setting and developed adequate strength to resist flow when subject to vibration. This is the vibration limit, age at which fresh concrete has undergone a sufficient degree of setting and developed adequate strength to resist flow when subjected to vibration. Vibrator, an oscillating machine used to agitate fresh concrete so as to eliminate gross voids, including entrapped air but not entrained air. Including entrapped air but not entrained air, and to produce intimate contact with foam surfaces and embedded materials. Y-cut apparatus. A penetration device used in test of hydraulic cements and similar materials. Y-cut needle, a weighted needle for determining time of setting of hydraulic cements. Viscometer, instrument for determining viscosity of slurries. Viscometer, instrument for determining viscosity of slurries, mortars or concretes. Viscosity, a measure of resistance of a fluid to deform under shear stress. Visual concrete, architectural concrete. Void cement ratio, volumetric ratio of air plus net mixing water. Volumetric ratio of air plus net mixing water to cement in concrete or mortar mixture. Void cement ratio, volumetric ratio of air plus net mixing of water to cement in a concrete or mortar mixture. Volatile material, material that is subject to release as a gas or vapor. Liquid that evaporates readily. Volume matching, combining constituents of mortar or concrete based on volumetric measurement. Combining constituents of mortar or concrete based on volumetric measurement. Volume change, an increase or decrease in volume due to whatever cause, deformation and time dependent deformation. Volumetric measuring, dispensing an ingredient based on volume. Dispensing an ingredient based on volume, either in discrete quantities or by continuous flow. Volumetric mixtures, equipment that uses measurements based on volumes of ingredients to feed a container that continually agitates and combines those ingredients for a production of concrete, also called volumetric measuring, and continuous mixing concrete equipment, VMCM. Volumetric mixer, equipment that uses measurements based on volumes of ingredients to feed a container that continually agitates and combines those ingredients for production of concrete, also called volumetric measuring and continuous mixing concrete equipment, VMCM. On 5 minutes please, okay? Wagner fineness. Wagner fineness. Fineness of Portland cement. Fineness of Portland cement expressed as total surface area in square centimeters per gram. It's called square centimeters per gram, determined by Wagner turbidimeter apparatus and procedure. Whale, a long formwork member, usually double, used to gather loads from several studs or similar members to allow wider spacing of restraining ties. When used with prefabricated panel forms, this member is used to maintain alignment. Wall, a vertical element, used primarily to enclose or separate spaces, and wall form, a retainer or mold so erected as to give necessary shape, support and finish to concrete wall. Warehouse pack. Warehouse setting and sticky cement. Warehouse setting, partial hydration of cement stored for a time and exposed to atmospheric moisture. Partial hydration of cement stored for a time and exposed to atmospheric moisture. Mechanical compaction occurring during storage, that is warehouse setting. Warping, out of plane deformation of corners, edges and surface of pavement, slab or wall panel from its original shape, caused by a normally occurring combination of differences in moisture content and temperature between two surfaces of panel. Taken independently, temperature differentials result in curling and moisture differentials resulting in warping. We can say out of plane deformation of corners, edges and surface of a pavement, slab or wall panel from its original shape, caused by normally occurring combination of differences in moisture content and temperature between two surfaces of panel. Taken independently, temperature differentials result in curling and moisture differences. Moisture differentials result in warping. That is, we have gone through various terms. Still, few pages are left, and you can say these shall be taken up. Meanwhile, we will continue our deliberations and these very important terms in coming time, because this is all important, very significant from every viewpoint. Title that we have gone through: quality concrete specifications, very, very significant. लेगा बस हो गया ट्राई लेगा पास से quality cannot be misunderstood. It should be thoroughly understood. It can be understood only when related terminology, related requirements, procedures, methods, and applications, which we can call as whole, are clear and known. We say application. Engineering is based on applications. Applications means we should know every aspect of what we are going to do. It's very elementary. I've been discussing we must have certain pragmatism on that. It's not that we have to go through each and every page, each every line. It's for understanding only. We have to understand it. And if understanding is missed, nothing is going to work. So video and videos are falling drastically, I think. I have to understand these facts. To understand these facts, clear in this regard. We have to understand what we have to do, and that's very important one. I'll leave it here for you to continue to think on what should be done, what should not be done. In this regard, I take your leave now. Hope you enjoyed.